some of the advantages and disadvantages of all those different graphs, how to create them, and a lot of problems that are found in Excel graphs. Okay, just to introduce myself, my name is Jessica Pruszynski. I'm an assistant professor in the Division of Biostatistics. And here's just the general speaker disclosure form. I'm not getting anything out of it, so I have nothing to disclose. And at the end, please help us out by filling out this evaluations. Okay, so today we're going to be talking about mainly 5 things. We're going to look at the 2 different types of statistical graphs, how to go about creating graphs in Excel, some of the qualities of what we look for and what we would consider a good statistical graph, some of the more commonly seen problems when people use Excel graphs, and steps to correct those problems. Okay, so generally when we talk about statistical graphs, there's 2 different types. There's exploratory graphs and there's presentation graphs. Exploratory graphs, if you're just trying to summarize your data in some way, it might help you see if there's any problems with your data, if there's any outliers, if you have a lot of missing data. Basically just a way for you to visualize your data set, especially if you have a very large data set. And just, as I said, just exploring your data. What is there? Presentation graphs are, once you've done a statistical analysis, what is the best way to display them? For example, if you've got a scatter plot and you fit a regression model, what's the best way to display that? Okay, the first one we're going to talk about is the pie chart, probably one of the more commonly recognized statistical graphs. Okay, we use the pie chart when we want to display a qualitative variable with a small number of categories. As we'll see in the example we're going to look at, once you get more than 3 or 4 categories, it becomes very, very difficult to distinguish some of the different categories. So all the pie chart does is it just divides a circle into slices based on the relative frequency of each category, the percentage associated with each of the different categories in your model. Okay, so here's our example. Suppose we surveyed several people and we asked them what's the most important quality we look for when they're choosing a restaurant to eat lunch at. So some people selected food taste, habit, food quality, and so on. The numbers you see in the second column are just what we call the frequency, the number of people who selected that particular option. Okay, very, very easy to create a pie chart in Excel. Just go into the Insert tab, select the Charts option, pick the pie option, and there you have it. Now the problem we see with this is we are looking at something with 6 different categories. Now habit has 10, food quality has 9, and convenience has 8. Because of this number of different categories, you're really not able to distinguish very much difference between those 3. And once you get any more categories involved in this type of graph, the slices become very, very small. You're not really able to get a good description. Okay, so that's just how to create a pie chart. You would only use those if you had a very small number of categories. I would not recommend using them if you had any more than 4 categories. Okay, the second option, if you have qualitative data, if you're just looking at categories, no numbers, is the bar chart. It's very much easier to visualize data with a bar chart than a pie chart. Generally, if you come to us for an analysis, you're going to see a bar chart a lot more often than you would a pie chart. I don't think we really do much pie charts in our department. Now, the advantage of the bar chart is that you're able to display data with a lot more categories. Okay? So, now what Excel calls the bar chart is the column chart. If you select the column option, then you're going to get a whole bunch of different things you could choose. This again is the same data we looked at before. However, you're able to distinguish a little bit more difference in these 3 right here, where before with the pie chart you really weren't able to tell which of those was larger. Here you're able to see there's more people selected habit than food quality, more people selected food quality than convenience. Okay? So that's the bar chart. There's really no limitation on the bar chart as long as you have categorical data. As long as you're not looking at like 200 different categories, you probably wouldn't want to use the bar chart then, but if you have larger number than 4, I would recommend using the bar chart. Okay, now the histogram, a lot of people confuse the histogram and the bar chart. The histogram looks very, very similar to a bar chart. It displays quantitative data rather than qualitative. So if you actually have numbers, you're looking at data that could be continuous, then you want to use the histogram. Now, Excel 2003 does not do the automatic histogram. So the instructions I've given you in the PowerPoint describe how to do it in Excel 2003. I was going to show it to you in 2007, but this computer doesn't have 2007. Okay? All right. So what we have here, instead of, we still have another frequency distribution. This time we're looking at the number of hours a medical student spent studying at a particular date, for example. Okay, so they've selected 2 through 8 and with their associated frequencies. All right, now the reason we would use the histogram here is because the number of hours is not continuous. We could have people reporting somewhere between 2 and 3, for example. It could be continuous. People could say, I spent 2.6 hours studying. And that's why we would use a histogram, just because the data could be on a continuous scale. Okay, so to create a histogram, this is one of the options that Excel does not give a default for in 2003. So you have to manipulate Excel to get it to what you want it to do. So you create a bar, just create a basic bar chart using the data. Now the trick here, what you have to do is select only the data column with the frequencies. Otherwise, it will give you a two-dimensional bar chart with a column representing each of the different options. So you just have to change the data using the select data option and then set the gap in between the bars to 0. So this is what you would have. If you go back and look at the bar chart, you'll notice there's a gap between each of the different columns. In the histogram, there is no gap because there's no cutoff. You don't have discrete categories. There could be something in between those, in between 2 and 3. Now, if you do it in 2007, if you just go create the bar chart, there's all these different options for different types of bar charts you can create. One of them will automatically produce the histogram if you're in 2007. Okay, now the next one is the line graph. Now, you probably may have referred to it as a trend plot. Basically, if you want to see what's the trend over time. In statistics, we sometimes refer to them as frequency polygons. Again, it's just another way to demonstrate a frequency distribution, just with a different type of method. Now, when you put your data into Excel, it must be in the form of a frequency distribution. And once again, select only data from the frequency column. And this is what you're going to get. Now, when you look at the default in Excel, it doesn't always give you the markers. Some people don't like the markers. By markers, I mean these things right here. You can put those in. It's just one of the options that you can select in Excel. If you don't want axes, you don't have to put those in there. You should always have a title on any of your graphs you do in Excel. Okay, but this way you're able to see how does the study hours, what is the frequency of study hours. And so you see we start out with, say, 2 people or 6 people who spent 2 hours studying, and then we take a dip, and then we slowly increase till we have 6 people spending 5 hours studying, and then as the number of hours increases, we're able to see that the frequency of people who are studying that much is decreasing. So line graphs are an excellent way to see how your data is behaving over time. Now, the last type of graph we're going to talk about today is what we call a scatter plot. This is just a graphical view of pairs of measurements on 2 variables. So what we have here is we have an ID column. Basically, we have 20 students in our study, the number of hours they're taking in a semester, and then their GPA at the end of the semester. So we want to see how does the number of hours credit hours a student takes, how does that impact their GPA? Yeah. Okay, so To do this, you're just going to go to Insert, Chart, and select Scatter. Now this is the default Excel gives you. Now there are lots of problems with this graph, which we'll talk about in more detail in a few minutes. Now when we create a statistical graph, we do not want to see all this white space. Okay, we want our data to take up as much of the graph as we can. So the first thing you would probably want to do when you are creating a scatter plot is change the axis limits. You might want to set it from, say, 8 to 20. Because one of the problems with Excel is that its default tends to overinflate what's actually happening with your data. Okay, so that's just how to create the basic scatter plot. So for example, each one of these represents a pair of data. So this point right here, for example, this would represent a student who took 10 hours and has about a 3.33 GPA. So this point right here represents student 1. And each one of these points represents a different student. They're each going to represent a certain number of hours and a certain GPA, which you can see on this vertical axis right here. Okay, now when we do a scatter plot, sometimes the next thing we want to do is look at a regression analysis. If we just want to see, for example, we want to see is the number of hours a student takes predictive at all of their GPA. Is it significant in affecting what their semester GPA is at the end of the semester? That's what we might want to see. Another thing we might want to see is I want to be able to predict a GPA if a student, say, took 12 hours. So that's another thing we would use a regression line for. Okay, so in Excel, you are able to do a regression analysis, and you are able to overlay the fitted regression line right on top of the scatter plot. All you have to do is just tell Excel to add a trend line, and you want it to display the equation and display R squared. If you don't select that, it's just going to give you a line. It's not going to give you any information about the line. So here, you can see, here's the regression line, here's the equation, and here's R squared. Now the regression line, we have a positive slope, so that means for every 1 unit increase in number of credit hours, the average GPA will go up approximately 0.15 points. Okay, which you can see we have a positive association here. Then we have the R squared value. This is just a measurement of how good a fit our model is. Basically, what this R squared tells us is that 67% of the variability in the data is accounted for by the model. So that's what we would consider a fairly decent fit, just based on the R squared. Now, R squared is only one of the factors we use to determine adequate model fit. But it's one of the easier ones to understand. Okay. Now, as you've seen, we have several different options for graphs in Excel's chart wizard. However, it does have its limitations, like any type of software package. Some of the common statistical graphs that you'll see often in literature are not available in Excel. There's the dot plot that Excel will not do. That's very similar to a bar graph, but instead of the columns, we have dots instead. There's the box plot, which we would use to determine is our data symmetric, we have any outliers in our data. And there's the stem and leaf plot, which is just another variation of a bar graph. Now you can, if you do a lot of manipulation with the available graphs in Excel, you can find some way to get them out, but it's very, very difficult to get some of these out. Okay, so when we're looking for a graph, we're creating a graph in Excel, and really any type of statistical graph, there's 6 different qualities that we look for. We want to be able to portray the information as it really is and not distort it to make it look like it's saying something that it's not. Okay, we don't want any distracting elements. For example, you don't want to put a whole bunch of wild colors in there that aren't needed. The axes should contain the correct range. An example of that is like the scatter plot that we saw earlier. Should always label the axes. When people look at a graph, there should be absolutely no question about what that graph is representing. Should have descriptive titles, captions, and legends. And as we're about to see, the default graphs in Excel meet very few of those criteria. So generally, when you create a graph in Excel, you've got to do quite a bit of modification to make it up to par. Okay, Now here's an example of something researchers like to do a lot. They like the third dimension in Excel because they think it looks cool. Okay? This is not optimal. I don't know about you, but I have no idea what this graph is telling me. Okay? First of all, there's no legend here, so I have no idea what each of these different colors represent. Okay? You can't really tell what's going on. And if you ever have put a third dimension in a graph, there should be a good reason for it. It should represent something. This thing is just there because. Alternative to doing this would probably be to do a multi-dimensional bar chart, okay, with multiple columns for each category. That would be a better alternative than this. This is completely meaningless. Unless you've got a lot of time to explain to somebody what's going on, it's not going to get your point across, and it will get rejected if you submit it for publication in a journal article. Okay, now this is another problem with Excel. When Excel produces a graph, it has a default aspect ratio it always goes with. The height-width ratio when you're producing a graph is extremely important. If you stretch out the graph or squeeze it down just a little bit, it's going to look like it's saying something totally different than it was earlier. Now the top right here is the default in Excel. It's what it automatically produces. If you just look at it, it looks like it's making a very bunch of sharp increases and decreases with not a whole lot going on in between. Now if you stretch it out a little bit, I believe it's twice what it was before in Excel, you can see it's not quite making those sharp jumps and falls as it was. You've got a little bit more of a valley in between. So you need to look at your data, look at what it's actually saying, and make sure your graph is representative of what the data is actually saying. Okay, now this is the problem that we saw in the scatter plot earlier. Now the chart on the left is the default. Now for some reason Excel likes to start its graphs originating at 0. Okay, that's not always optimal. You do not always have to start them right at 0. Okay, okay. The problem with this graph right here is that we have all this white space right here, and that's forcing our graph to be squashed down quite a bit. It's not representing the true variability in the data. So what we do is we change our x-axis or horizontal axis to only range between 3 and 10. And instead of letting our y-axis go between 0 and 16, we set it to go from 4 to 16. Okay, since that's really where we're seeing our minimum data point. We picked 4 just because that's about where that one is right there. Now if you look at the one on the left, they're all very squashed. Looks like there's not a whole lot of variability in those data sets. If you look at this one over here, you can see they're spread out a little bit more than are seen over here. So you want to make sure, this is one of those examples of making sure everything is set appropriately. Okay, and you're actually representing what's truly going on in the data. Okay, now in Excel, there's problems like I just discussed. There's also problems with just the visual aspects of the graphs. Okay, they're not optimal. They're not appropriate for publication or presentation. If you submit them to any journal, they're more likely going to get rejected and tell you to redo them. Okay, now the good thing about Excel is that it's very, very easy to modify these things. You can change the background, change the grid lines, you can change the colors, you can modify the legends to make it look however you want, you can change titles, you can change captions. It's very, very easy to manipulate, which is the good thing about it. One of the very few good things about it. Okay, now the background. Now if you create a graph in Excel, the background is going to be dark gray, regardless. I think they may have changed that in the 2007 version, but I know it is true in the 2003. If you create any graph in the 2003 version of Excel, the default background will be dark gray. Now this is not what you want. It's very distracting. It can hide features of the graph, especially if you have to do a graph with multiple colors. It can distort those. So all you have to do is just right-click on the graph and select Clear, and you'll have a white background. and your problem solved as far as the background is concerned. Now, grid lines. Now, when we create graphs using more formal statistical software package, grid lines are usually not present. Excel does these because it's used a lot in business. Okay? Now, what we've found is that these grid lines can overwhelm the graph. Especially when you have many, many grid lines on the graph. The data that's being represented can get lost among the grid lines, and they are usually, more often than not necessary at all. So all you have to do is just double-click the grid lines and select no grid lines when the dialog box comes up. Okay, now, if you absolutely have to have grid lines, you can put them in there. There's really nothing wrong with putting them in there as long as you don't go overboard. If you just want to put like 4 or 5, just to be able to exactly tell what the values on the graph are, you can do that. Okay, now the problem with Excel is that when you create the default graph, the colors can be kind of crazy. Okay, you don't really want neon colors on a graph that's going to be published. Okay, you need to think carefully about what the colors add to the graph. Now, sometimes using multiple colors is appropriate, but more often than not, different colors may not be necessary. You may select different types of lines to represent your different lines. For example, you might have one that's a solid line, one that's a dashed line, and one's that's a dotted line. Sometimes color is not an option in many journals, so you would need to not be able to use color. But again, very easy to select, very easy to fix. Just look in the options menu and you can select whatever colors you want. Okay. Now, legends are a little bit different. In Excel, it will automatically produce a legend whether you want one or not. Now, as we saw in all of our graphs, we were only looking at one dimension. We were looking at one thing on the graph, so you didn't need a legend. If you only have one thing on a graph, you don't need a legend. It's only when you have multiple things that you're trying to put on one graph where you would need a legend. For example, if you were looking at 2 trend lines. Okay, if you were looking like the trend line we did where we were comparing study hours and frequency, you might want to look at one different for males and one for females. So that's when you would want to put a legend on there identifying which trend line was males, which trend line was females. Okay, now, when the Excel places the legend, it always puts it as far outside the plot area as you can get. You want that legend to be inside the plot area. You want it as close to the colors as you can get it. Okay. You want to place it inside the plot. It's very, very easy to move it. Just select it and move it. Okay? Okay. Excel does not always create a plot that has titles. Any graph you select, any graph you create should always have titles and axis labels. Okay, as I said before, there should never be any hesitation when somebody looks at a graph. They should know exactly what it's representing. They shouldn't ask, well, what's represented on the vertical axis? What's represented on the horizontal axis? What is this graph telling me? Okay, you need to select an option that will have those labels. Okay, you need to make sure it has an axis, make sure it has a title. Okay, again, very, very easy to add those. Okay, so in conclusion, Excel does have several good graphing utilities. If you can't make it to us and you just need something very simple, you don't have time to meet with a consultant, and you just need something very, very basic like a bar chart, a histogram or something, then Excel is a very, very good thing to use. It's very, very easy to use, especially if you have no training in statistical software, you don't know any coding to use some of the more elaborate software packages. However, just because Excel creates it doesn't necessarily mean it's right. Okay, just make sure any graph you create, it has all the good qualities of what we would look for in a good statistical graph. Yes? Not that I'm aware of. I really don't use it a whole lot, hardly ever. There may be, I'm just not sure of how you would do that. Any other questions? Okay, that's all I have.